Alright. So how do you... So we're at maybe number 33. Earth is not a perfect sphere. Its radius, as well as the value of little g, vary with latitude. Calculate Earth's mass, given the acceleration due to gravity at the North Pole is 9.807 meter per second squared, and the radius of the Earth at the pole is 6,356.8 kilometers. So let's calculate Earth's mass.
You know that from like the, I guess the layer of, I guess, what's it called, of the Earth? No, the top of the Earth.
You're the only one to turn these lights on.
Huh? Like the.
I always try to flip these lights on.
I guess out of the.
It's weird.
I'm trying to keep myself in.
Yeah, I understand.
Like,
That last time you walked in here and the lights just came on.
you know, before you get to the solar system, it's like the in between the Earth and the solar system. What is that? It's like the
ring thing. What is it? It's not the
you know
galaxy
what
belt.
it is. You know what it is.
The asteroid belt?
It's like before you like if you're going up and you're leaving Earth and you pass the what? What is that? Well, yeah, the atmosphere.
Yeah,
right?
but I'm talking about. I know what you're
So
talking about.
there's the mesosphere and the
I guess the highest level.
No, I know exactly what you're talking about because you got to pass it and it protects us from the sun.
Yeah.
You talking about the stratosphere?
It protects us from the sun because of the.
The UV rays, yeah.
But what is that clear thing above the Earth that protects us from
and
the
then
sun?
it's the troposphere. The troposphere is high.
Because I
The
heard
troposphere.
that from that
No, he's looking for the high one though. The
Exo.
exosphere.
Exosphere.
So apparently, from that to the bottom of the ocean is like an 11-mile difference.
11 miles. 11 miles ain't enough.
Because I guess
No, you gotta be talking about the troposphere.
the trenches in the bottom of the ocean goes down 6 miles. Like that's the lowest part of the ocean. That's 6 miles, and when you go up 6 miles,
They'll put you back on Earth.
no,
Yeah, 5 miles.
Looks
I'm talking about
like
6 miles from land up.
Isn't that the ozone layer? That's the layer.
I believe it's the
That's what
ozone layer.
That's what it's called.
yeah, I was about to say because
Yeah,
the
maybe it's the ozone layer.
Yeah.
exosphere.
Yeah,
That's
that's
the
what
only
we're talking
thing we learned about in school.
Yeah, because I ain't never heard no ozone
We heard the stratosphere, but
Yeah.
we talking about, you talking about.
No, I mean, yeah, of course I heard the words, but I never learned them. The only thing I learned about is the
I'm talking
ozone
about
layer.
the
So I
other
think
layer.
you're right.
So yeah, they say it's like an 11-mile difference.
But well, hold on, let me Google because is the ozone layer something that the word that they use?
It's a
Is it
real,
savings?
it's a real word for it though. Ozone layer. So, I think.
Oh, okay, so that is a word. I'm thinking the ozone layer is just a smaller word for it. Astros.
Oh, you think for one of the spheres?
Yeah, I thought it was just another word.
And not ozone levels today. Protects us from the harmful UV rays.
10 to 25.
Yeah.
Maybe I'm wrong. I don't know.
No,
said
you
11,
yeah,
that
you
was
just said
close. You
that.
said it was something in there.
Yeah, that's
No,
what you
it's
said.
not. Oh, well, I know the bottom of the ocean, I know that's 6 miles deep. But
Them kilometers, kilometers is 1,000 meters. That's 100K meters, or 10,000 meters.
I want to know what's at the bottom of that.
So how many miles that is?
a lot of pressure.
Oh, it says it right there.
Yeah, but like, what?
25 miles.
Mhm.
I find it funny how people say if you keep swimming, you just gonna end up in space.
Just keep
Yeah,
swimming.
it is. People on that damn.
I can't believe they did that.
You just end up in space.
And Finding Nemo.
That's what it was. That's
Like, what did they think going down in that little thing that nothing was gonna happen? Jeez.
I guess they decided, I think they gave their family someone where they live. But I don't really know.
Yeah, it wasn't a descendant from, the old, couple that went to see the bed before they died.
Just,
All right, so we
Yeah,
got,
that's cool. I didn't be watching it.
okay, calculate mass, okay, the mass is, oh.
Acceleration due to gravity. Acceleration due to gravity, or G. A equals. Let me try to write bigger, so
thank you.
be more, so I can.
I'm just saying, I could never see some words in it.
Yeah, no, I got you. I can
Stand
feel
side by
it.
side, see that?
I always like big.
Is 9.807.
Thank you.
And the radius of the Earth at the pole. So here's our second known. Uh-oh.
That is some slow shit, right?
Radius of the Earth. 6,000.
I'm so glad I have my wallet here. I would have thought about it when I left it. I'm glad to see it too.
So
Then you just thought about it. I knew that it was your first, but I
You just saw it?
No, you just changed the problem.
I can't believe it.
He just changed 6. We doing 35. Which one we doing?
we'll do 33.
We doing 33. He just
Oh, well, then why I get F equals G? Oh, why? Oh, anyway, all right, go ahead.
So the first thing I noticed, I'm putting these together. Do I want to keep kilometers, or do I want to change it to meters? You usually want to change it to meters. That's usually first. Because if I have my acceleration, so let's go back to our equation too. F equals G.
Oh, okay, that's what
Big G M times big M over R squared. Every particle tracks every other with the force along a line joining them. The force is directly proportional to the product of their masses and inversely proportionate to the square of the distance between them. That would be if I had two. Gravitational force. So we're looking for Earth's mass. What is Earth's mass? So the question is M. F equals MA. Equals MA. I think we can eliminate the big M. Force of gravity.
What is a little M and big M?
Because mass, like one is mass and then one is the millimeters or meters. Because you said you were taking the kilometers and turning them into meters.
Oh yeah, that's what I was
I think. So what does that mean? What does that mean? Mass of meters?
Or is it millimeter? No.
No, that's a M and a big M. So it's like meters of masses or something. But you know how they always do it. So I'm sure it's like masses, meters. Or meters masses, some shit matters. Masses, meters. So it's something.
In order to get meters. Whoa. Also do times 10 to the 3 kilometers. Also times 10 to the 3, 6.3. Alright, anyway. But now, I'm pretty sure that my force is the same. That I need to relate F equals MA, which so there's a way I think we're gonna solve for, pretty sure we're gonna solve for the put that together, solve for those. Yeah, that's where they get that from. Yeah, so that's what I was gonna do too. So I know F equals MA. F equals mass times acceleration. Big M over R squared. Looking for yeah, so and then yeah, so that's why they relate. So that's why they cancel them out. Because I always know F equals MA. So now I can relate these two together and say MA equals big G, little m, big M over R squared. And then, since these M's are on both sides, in order to get my A, saying if I relate, these m's can cancel out, and then I'm left with A equals big G, big M over R squared. And then I know what the A is. A is G. So and then I could say little g actually equals big G M over R squared. But I'm trying to solve for Earth's mass. So to solve for Earth's mass, let's put the M. G times R squared divided by big G. Big M, R squared times little g over big G. So that's probably the hardest part for this question. Because it's saying what's Earth's mass, and then there's not a great equation that just says, oh, Earth's mass equals this. So what I can do with our equation, I know F equals MA. So that's the big step here, is setting a relationship and saying, okay, I know F equals MA. Now I also know F equals big G, little m, big M over R squared. So let me put MA and relate these two together, because I'm given my acceleration. In this equation, I don't have anywhere to put my acceleration. So and then I'm saying, okay, well, A, if I go ahead and divide by little m on the other side, since I know my A, I can solve for the rest of this, or I could try to put my big M in the right place since I know what this is. So let me isolate this little m, get that out of the way. So that's why I divided by a little m, cross that out, and then you're left with A equals big G, big M over R squared. So and then I have G, because A equals G, which they say in the question too, given the acceleration due to gravity at the North Pole is this amount, 9.807 meter per second squared. Does that make sense? That's the big thing with that one. So and then it's saying Earth's mass, okay, big M equals little g, R squared over big G. So that makes sense. So the G that we're given, 9.807 meter per second squared. The radius, R squared, 6. So now I could do all that. 3.3 times 10 to the 1, 2, 3, 4, 5, whatever. Big G, my big G is a constant. The 6 points. Yep. And that should be meters per second squared as well.
I know looking at that, if I didn't would you break that part? Oh my God, I probably broke down.
Yeah, that's the
Just looking at the
big.
equation, just like.
Yeah, that's the big thing. That it's kind of weird.
Did you get an answer for that?
It was an answer. It was a solution. You go back.
Yeah, I didn't really.
No.
I figured since.
Wait, did you multiply the 9.807 by 6.3?
Yeah.
Well, you got
6357 times 10 to the 3.
I think it's square though. Or does it matter?
Yeah, it's still squared. Because you could do 6357, 6357, and then still do x to the third, and then b to the second. So you could do 6357
Times 10 to the third.
times 10 to the fifth. You could do that.
Are you adding exponents?
Mm-hmm. Yeah, you can add those exponents.
Huh.
Let's see here. 6357 times
For
10
G?
to the 3.
Well, y'all probably know up here for G. What's the exponent? 10?
10 to
11? Okay, thank you.
Squared times 9.8 divided by 6.674 times 10 to the 11. So yeah. Yeah. Anyway, let's see right there. B. Compare this with the accepted value of 5.972 times 10 to the 24. This is slightly da. So the equation we use to find G assumes a sphere, but we already noted that the radius da. The calculation gives the mass for a sphere, the radius ignores blah blah blah. Alright, so oh, that's why big G is to the negative 11. That's why it looked kind of weird to me. To the negative 11. And that is a Newton meter squared over kg kilogram.
Whoa. Wait. Oh, okay. Well,
Alright, but what happened, can you go back to what happened to the seconds? Because I can see how the M's cancel out, but what happened to the seconds? Did we just drop it because it was doing fast?
A Newton. They put it together with the Newton. A Newton is
didn't you say what the anytime you do kilograms and meters per second?
exactly meter per second squared. A Newton is meter per second squared.
Okay.
Kg times Newton per meter squared. Kg times meter per second squared. Newton. Yep, 1 Newton is kg times meter per second squared. So let's do the units. So we had gravity, meter per second squared, radius, we have meters squared, and G is in Newton meter squared over kg squared. Okay.
That's a lot.
Now I got meters cubed over second squared. And I'm gonna do the inverse of this so I can see it easier. Kg squared over Newton meter squared. Following? Alright, so now let's change the Newton because it'll help me in the long run. Yeah, let's just write it out. Meter cubed over S squared times kg squared over a Newton is a kg meter per second squared. And then we have times a meter squared.
You lost me right there.
Following. Okay. A Newton is kg meter per second squared.
Right, correct. I'm
The
trying to
amount
figure out where's
of force per area.
did you break down?
The amount of weight. Speed of a weight.
Where it says second square and meters to the third, did you break something down? Second time. Yep, yeah, right there.
Right. So I did the inverse
Right.
so that I could see it easier.
Okay.
Meter per second squared times meters squared. Alright. G is the acceleration, meter per second squared. Radius is in meters, so meters squared. Alright. Divided by big G is Newton meter squared over kg squared.
I follow.
Alright. So then meters cubed divided by S squared, so I can see it easier. I did the inverse times. I put the kg squared because it's the
Hold on, let me
inverse.
just stop
What
you.
I'm doing.
You said meters. Where are you getting meters cubed from?
So that's the gravity. Gravity is meter per second squared, and then
Right.
radius squared is meter squared.
Right.
So now I just put these two together because it's multiplying.
Is there like an invisible one by the meters or something?
Right.
Like to where you add them?
Multiply. Two M's, one M. 1M times 1M squared. M times M squared, or
Okay. Okay. Okay, I got you. I see it.
yeah.